Hello, 7th graders. This is Mrs. Locke here with you. Not to do video notes, though. This is actually the lesson. Sometimes when I'm gone, I will teach the lesson on video. And it might be because I want the notes to look a very specific way, or it might be because I want to talk about the content a very specific way. But sometimes your lesson when I'm gone will be on video. So you should have this page. It's front and back. It's the problems from the book. And since I'm believing that I think I could just talk about the lesson in the way that I like, I think I'm going to do that. So you don't need the whole book with you. But what we're talking about today is called a matrix. And a matrix is really just a shorthand table. So I'm going to put over here the word matrix. Same rules apply. If I use color, feel free to use color, but you can do these whole notes in pencil if you see fit. A matrix is a quicker way to organize data. It actually, I like to think about them as like a nickname. So my real name is Danielle, but lots of people call me D. And that's my nickname. It's the short version of my name. A matrix is a short version of a table. So what you'll notice in this particular table, this table is talking about weekly working hours. And if you notice that little picture on the side, like during the 1800s and early 1900s, labor unions were formed to improve working conditions. So the miners in this picture may have belonged to the American Federation of Labor, one of the first unions to include African American members. And they're keeping track of weekly working hours, and they have been decreasing over time. So that's the data set that we're working with today. So what we're going to do is we're going to create a matrix for this, and we're going to call it matrix A. Now, what we know is that when we're doing a matrix, really what we care about here are the data sets. So I'm just going to draw a bracket down here because this is really what my matrix will look like. So my matrix is going to have two columns, and you can see it's saying something about that right here. Two columns, column 1, column 2, it goes from left to right. And then I'll have 6 rows going down. The rows are counted top to bottom. What they're telling you here is that this particular row would be labeled row 3, column 2. Oh, excuse my hiccups. Row 3, column 2. And so, in fact, this matrix would be called a 3x2 matrix because you talk about the dimensions. The dimensions of a matrix are the rows times the columns. So I might say that this is a 6x2 matrix. All right, so we're going to make a matrix and we're going to call it matrix A. So here I go. I'm going to have row, I would love for my, I usually use 3, so that works. So I'm going to have 47.7. I'll have 56.4. I'll have 60.1, 64.2, 55.9, and 50.2. And then I'm going to put a bracket around that, like this. And we would call that matrix A. And you want to use the brackets to designate that you're talking about a matrix. So that's column 1. Now I'm going to put in column 2. So I'll have 35.9, 30.6, 30.8, 26.9, 37.6, and 33.1. And I'm going to make my bracket on the other side. This would be, my dears, matrix A. All right. So we know that 47.7, I can designate that as row 1, column 1. And I have seen this written a very specific way, but I don't see it right now. So give me a second. I'm going to look it up and see if I can find it. No, I don't really see it. Okay, well, maybe I don't have to teach you that if they don't have it in here. So we'll just identify it. Would you please tell me what number is in row 4, column 2, and what number is in row 6, column 1? Pause this movie right now. All right, if you're back, that's because you have finished writing what numbers would exist in those spaces. What we're going to do is there is something that you can do to scale up a matrix, and that is that you could like multiply the whole matrix by 50. At this point, I'm not quite sure what that means. Yeah, because let me see if I look back. If I multiply it by 50, like I don't know why I would do that, because 50 times 47.7 is going to be something really big. I mean, I know why. Oh, because I know what it would do. So I would like to do it, but like, so it says that, for example, if we go back up here, Australia is 47.7 hours per week, but that let's say somebody was working 50 weeks of year, they would work 50 groups of 47.7. So instead of, if we're going to change matrix A from hours per week to hours per year, we would multiply the whole thing by 50. So we're going to multiply matrix A times 50. And ultimately what's going to happen is we're going to scale every single one. Ooh, I might have run out of room here. I know you can't do this, so you might have to write smaller, but I can. I think I can do that. Look at me go. I apologize that you aren't going to be able to change yours exactly. So just try to fit it on there best you can. All right. So what I'm going to have to do is I'm going to have to multiply every single part by 50, and I'm going to ask you to help me do that. There's 6 rows. 1, 2, 3, 4, 5, 6. So I'm going to multiply 47.7 times 50. Do I have a calculator? The answer is yes. 47.7 times 50. Let me see. I got 2385. 2385. Notice that this new number, replaces the old number in the same location. And that's really important. When you're going to multiply or when you're going to scale a matrix, keep the numbers in the same place. So I'm going to do another one. 56.4 times 50, boop, 2820. So if someone worked an average of 56.4 hours a week, that would be 2,820 hours a year. I'll do another one, 60.1 times 50, 3,005. All right, I'm going to move over to column 2, 35.9 times 50, 1795. Now here's the deal. I'm going to ask you to finish scaling the matrix by 50. Finish multiplying it by 50, each part, and put them where they go. You can pause it if you want, because I'm going to keep going. So if you're ready to rock and roll and you want to move on, let's do that. So let's say we have two matrices here. Matrix is the singular form. Matrices is the plural form. I don't think people say matrices. I think it's matrices. Now let's just say that matrix B provides the cost of a medium pizza, a medium salad, and a medium drink at two different pizzerias. You've got on the left the Pizza Palace and on the right Tony's Pizzeria. Now matrix C, I'm going to zoom in. Matrix C provides additional charges for large items at the pizzeria. So you've got matrix B, which is size medium. So I'm going to write just medium right here. Boom. And then you've got matrix C, which is size large. Boom. So matrix B and matrix C. So let's just say that what we want to do is add some parts. So if we wanted to use these matrices to calculate menu items, we could do that by adding the matrice. Okay, here's the deal. When you add a matrice, you do want to add the same parts. So let's say that let's take a second and just set this up in general. We're going to have 890, 235, 150. That's one matrice. This is matrix B. Ooh, I don't want to put that there. All right, I'm going to finish it. 910, 265, and 160. We'll label it down here instead. And then we're going to add some of that to matrix C. We've got 250, $1.65. And then we've got 225, 125, and 050. Meow, 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 meow. So all of that is going to be matrix C. We've got pizza, salad, and drinks. And this is the medium, and this is the large. We've got Pizza Palace and Tony's Pizzeria. Pizza Palace and Tony's Pizzeria. That's a lot of setup. So if we wanted to get the size, let me see. What do we want to do here? if we wanted, oh, this is just the additional charge for a large. So additional charge, like an upcharge. So that's not the cost of a large. That's the additional charge if you want a large. So let's say we wanted a large pizza at Pizza Palace. We would do the pizza and the upcharge to a large. So Pizza Palace large is going to be $8.90 plus $2.50. All right, that would be $11.40. I mean, we could figure out what the upcharge was for large for everything, I think, if we add the little parts. That may or may not be a good thing to do. Let's do that. I think we're just going to make another matrice. We're going to do it. So we're going to make a third matrix because we're going to practice. A large, this is the, I think we should change this though to additional charge. Additional charge. Okay, so now then we could make a matrice labeled D, and D could be our large charge. Large and in charge. All right, let's do it. So first, let's find the pizza for the Pizza Palace. So that would be $11.40 for a large pizza. If I wanted to get a large salad, then I would have to do the medium salad plus the upcharge. So that would be $3.35. I want to know, where is this place? Because it is affordable and it will help me save money. If I want to know what a drink is, a large drink, I'm going to go to the Pizza Palace. I'm going to find the medium, and then I'm going to get the upcharge. So I think that's going to be $2.05. Now I want to go to, what is that place called again? The pizzeria? No. Tony's Pizzeria. So, I keep hiccuping in these videos. I'm sorry about that. Here's $9.10 plus $2.25. Let's see. So would get me a large pizza. So that would be $11.35. And then if I wanted to figure out the salad at Tony's Pizzeria, nope. Tony's Pizzeria, I'm going to have $2.65 plus $1.25. So that's going to be $3.90 for a large at Tony's Pizzeria. And then if I want to know what Tony's Pizzeria costs for a large drink, I'm going to add 1.60 and 50 cents. So that's going to be 2.10. Now, if you disagree with me and you think I'm wrong and you'd like to change your decimals, just do. It's fine. I'm adding these in my head, so I might get one wrong. This would be matrix D. Matrix D is the sum of matrix B and matrix C. I could say matrix B plus matrix C is the same as matrix D. I could even write that as a little sentence. Matrix B plus matrix C is the same as matrix D. You can add them together. I think we're going to practice that right now. We're going to practice adding and subtracting. Oh my gosh. So let's set up, because we're not going to do letter C, because we're not doing that today. That's tomorrow's lesson. Oh, and then you have one on your own. So this video is almost finished. Here I go. I'm going to add A plus B, and then negative A. Oh, we're going to get it. I'm excited. Okay, so here I go. I'm going to set it up. I'm going to have a 3, a negative 2, a negative 4, and a 6, a 2.5, and a 4. And I think that I spread this out just a little too much. So let me try again. I don't want to run out of roomsies. We're going to have a 3 and a negative 2, a negative 4, and a 6, a 2.5, and a 4. This is matrix A. And we're going to add it to matrix B. Matrix B is 5 and negative 4, negative 1 and 3.5, 2 and a 1. And then we're going to come up with our new matrix. Yeah. Okay, so I just want to make sure that I'm adding corresponding parts. So for example, I'm going to add 3 and 5, and in my new matrix, my number is 8. So then I'm going to add negative 2 and negative 4, and in my new matrix, my number is negative 6. I'm going to go to column 2. Column 2, it's got negative 4 plus negative 1, so I'm negative 5. And then at second row, column 2, 6 plus 3.5 is 9.5. All right. So now I'm going to move on to the third column, because it doesn't matter how many columns there are or how many rows there are. When I'm adding, I want to add the corresponding parts. So I'm going to add 2.5 plus 2, and I've got 4.5, and then 4 plus 1 is 5. So now this is my new sum matrix C. What we did was we add the corresponding parts. That's what we did. Now, if we want to make an opposite of A, the opposite of matrix A would be, if I'm using opposites, instead of positive 3, negative 3, instead of negative 2, positive 2. Let me see. Instead of negative 4, positive 4. Instead of positive 6, negative 6. Instead of 2.5, the opposite of that is negative 2.5. And the opposite of 4 is negative 4. So that's how I would make the negative matrix. What I'd like you to do is, with your talking partner, you're going to try and find the missing matrix B. Matrix A minus matrix B gets me to matrix C. So what does matrix B look like? Down here, you're going to build matrix B. You might, 3 rows. You might need to use a calculator. You might need to maybe do a number line. You might need to use fact families. Talk to your partner about how you can figure out missing matrix B. Friend, that is your lesson today. I hope you liked it. I'm recording this before I leave, and ultimately the last conversation we had together was that I should kind of trust my judgment and how to explain things to you instead of the way that the book does. So I hope that this was understandable. It's a shorthand or a shortcut way to use table data and to work with table data. So please make sure you have everything that I wrote and that you do the extra with your talking partner, and I will see you tomorrow. I hope.